Hello students, welcome back. Let us resume our discussion in section 1. We went through all the major topics except one, some application problems. Alright, let's begin. Find the height of the tree in the following picture. We have a nice 3D picture here. But very often 3D pictures give you too much information. So in reality, it's not really helpful. So can you produce a 2D picture? Well, stop the playback and draw something. So okay, we can draw a right triangle like this. Does it look okay? No, it doesn't look okay. Let's get out of here. Okay, and then let's redraw the picture here on the right hand side. Okay, alright, we have a right triangle like this. And then let's suppose this is a right angle. Height of the tree, h is unknown. And here we have 532. And this angle is 25.7 degrees, so we know that. So from this information, we have to find out the height of the tree. Now, before starting this problem, please make one decision. Sine, cosine, or tangent. Which trig ratio do you have to use? Sine, cosine, or tangent? Stop the playback and think. Did you get it? It should be tangent. Why not sine? Why not cosine? The key point is you don't know the hypothesis here. Not hypothesis, excuse me. Hypotenuse, yeah, that's the proper term. So you don't know the hypotenuse here. Sine is opposite of hypotenuse. Cosine is adjacent over hypotenuse. We don't know the hypothesis. We don't know the hypotenuse. So we cannot use sine or cosine. It has to be tangent. So how do we make it work with tangent? Well, tangent of 25.7 is opposite over adjacent. H over 532. From here you can solve for h. Flip this denominator to the other side, multiply out, and then punch in the calculator. It turns out tangent of 5.7 degrees, this one here, turns out to be 0.48 something, as I just highlighted in blue. So times 532, we end up with 256 degrees. 256 feet, excuse me. Right number, incorrect unit. Sorry about that. 256 feet. It's a big tree. Next question. Oops, sorry about that. Determine the distance to the flagpole, which is 60 feet tall. Which trig ratio do you have to use? Sine, cosine, or tangent? Did you make a decision? Well, let's see. The question here is again the hypotenuse. We have this right triangle on top with degree 18 degrees. What's the hypotenuse here? Distance to the top of the flag. We don't know that. But this hypotenuse down here for the second right triangle, eyes of the observer all the way down to the bottom of the flagpole, we don't know that either. In fact, we have this kind of simplified picture. For simplicity, I labeled it as x, a, and b. X is the distance for the flagpole that we are interested. I don't know the hypothesis. I don't know the hypothesis. I don't know the opposite either, but flagpole is 50 feet tall. So we do know this. A plus B add up to 60 feet. And that actually is quite useful, it turns out. How do we get it right? Well, let's look at the blue triangle first. Blue triangle is a right triangle. And we want to find out A and X, the relation between A and X. No idea about the hypotenuse. So we're going to use, as usual, tangent. If you know hypotenuse, sine or cosine, but no hypotenuse, so it's going to be tangent. Tangent of 18 degrees is A over X. That's what I'm going to get from this blue right triangle on top. Likewise, tangent of 14 degrees is B over X, and that comes from the red right triangle down below. And then this one here, A plus B add up to 60. Feet. So what's the structure? Can you solve it? Well, we have 3 unknown variables here. We don't know X, we don't know A, and we don't know B. But we have 3 equations. As for tangent of 18 degrees, you can punch in the calculator, you can find out. Tangent of 14 degrees, again, you can punch in the calculator and figure it out. No problem there. We have 3 unknown variables, A, B, and X. Okay, how do we get it done? Okay, from this point on, it's an algebra problem. It's a system of equation problems, but it's a system of nonlinear equations. How do you get it done? Well, here we have relation between A and B. So we'll solve for A, solve for B, and put those into the third equation. So from first equation, A is X times tangent of 18 degrees. From second equation, B is X times tangent of 14 degrees. So this is blue, and this is red, and I can put those into the third equation. If I do that, what you get? A is X tangent of 18 degrees. B is X tangent of 14 degrees. That adds up to 60 feet. Tangent of 18 degrees, that's a number. Tangent of 14 degrees, that too is a number, so no problem. I can factor X out. Tangent of 18 degrees plus tangent of 14 degrees. That's going to add up to 60. And these were just numbers, so I can punch in the calculator. Or maybe later. 60 divided by this quantity here. And alright, now it's time to put into calculator. If I do that, 60 over that, oh well, I got tired of it. Let me just open up the solution here. Okay, alright. Tangent of 18 degrees, tangent of 14 degrees, we got these two. And then so for A, solve for B, and substitute in. And then 60 feet is x times that. So 60 feet over these. Punch in the calculator, 0.324 something, 0.249 something. Okay, alright. Run your calculator. I'm getting about 105 or 104.5 feet. Approximately 105 feet, I guess. By the way, there is a way to do this problem with law of sine, not by tangent, but by sine, and that method will be a little bit easier and more straightforward. But we'll have to wait a couple more weeks. Alright, we just had a couple of tangent problems. One straightforward, one not so straightforward. Do we have something else? Let's open this problem. The elongation alpha of a planet is an angle formed by the planet, Earth, and the Sun, as illustrated in this picture. And the maximum elongation of Venus is 46.3 degrees. Yeah, that angle here. And maximum will take place, of course. This angle is a right angle, so we have a right triangle here. And here, do we know the hypotenuse? The distance between Earth and the Sun? Yeah, we know that. One astronomical unit, or 9.3 times 10 to the 7th power of miles. So we know the hypotenuse. From here, we can figure out the distance between Sun and Venus. So we know the hypotenuse, we know the angle, find out the opposite distance between Sun and Venus. Which trig ratio do you have to use? Sine, cosine, or tangent? It should be sine. Opposite of a hypotenuse, that's sine of alpha, 46.3 degrees, and we know the hypotenuse, 1 AU, or 9.3 times 10 to the 7th power of miles. So the distance between Sun and Venus, let's say it's opposite, y over hypotenuse, 1 AU, is sine of 46.3 degrees. So y is 1 times sine of 46.3 degrees, and then that's AU. Astronomical unit, and one astronomical unit is 9.3 times 10 to the 7th power of miles. So you can punch this into calculator, sine of 46.3 degrees, times 1 will not change anything, and then to that number, multiply 9.3 times 10 to the 7th power, you're going to get this distance in miles. Good luck. Did you get it? Well, here's the solution. So sine of 46.3 degrees, 0.722967, that's the sine value, and that times 9.3 times 10 to the 7th power, so 6.72 times 10 to the 7th power of miles. Alright, now we did an application problem on sine, and then we have one more, but we are running out of time, so I'll leave that to you. Looks like this is gonna be another tangent problem. I shouldn't have said that. I gave away a bit too much.